Okay, let's jump right in. You've probably heard the saying, numbers don't lie, that data is just fact. But here's the thing, data tells stories. And just like any storyteller, it can be super persuasive, really enlightening, or, yeah, incredibly misleading. So today, we're going to put on our detective hats and figure out how to tell the difference. And here's our first case. It's a real head-scratcher. If you look at the numbers, you'll see this weirdly strong connection. When ice cream sales shoot up, so does the number of people getting sunburned. So what's going on? Is that pint of cookie dough in your freezer secretly out to get you? This is the mystery we're going to solve. Now, to crack this case, we have to understand how a data story gets built in the first place. Because a lot of the time, the deception starts right at the beginning, with the choices someone makes before they even collect a single piece of data. So the very first building block is something called a variable. Just think of it as the what in your story. It's the thing you're actually measuring. Could be ice cream sales, a person's age, their favorite kind of pizza. They call it a variable because, it varies. It's different from one person or one day to the next. And these variables come in two main flavors. First, you've got categorical variables. These are basically just labels or groups, like dog, cat, or fish. Then you have quantitative variables, which are actual numbers you can measure, like height or temperature. And this first choice, are you sorting things into buckets or are you measuring them? That decision shapes the entire story you're about to tell. All right, so once you figured out what you're going to measure, the next big question is, who are you going to ask? And let me tell you, this single choice is where so many data stories just go completely off the rails. I mean, you can't survey every single person on the planet, right? Of course not. So you take a sample. It's the process of picking a smaller group that hopefully represents the bigger population you want to understand. But here's the catch. If you pick your characters for the story badly, your entire story is going to be biased from the get-go. Let's look at a wild, real-world example of this. Back in 1998, the pro wrestler Jesse the Body Ventura was running for governor of Minnesota. And every major poll said he had absolutely no chance. The data story was crystal clear. He was going to lose big time. But then he won. So what on earth happened? Well, the pollsters were only talking to people they called likely voters, people with a track record of voting. What they totally, completely missed was this huge wave of young, first-time voters that Ventura's campaign had fired up. They weren't likely voters by the old definition, so their voices, their story, was never even part of the data. And that, my friends, is a perfect textbook case of sampling bias. Because the sample didn't actually represent all the people who were going to vote, the story the data told was just wrong. But just picking the right people isn't the only trap. Oh no. Even if your sample is perfect, the way you ask the questions can create all these hidden biases, these sneaky little forces that can twist the answers you get. Think of them like an unreliable narrator in your data story. And there are a ton of them. You've got self-interest bias, which is when the people funding the study really, really want a certain result. You've got loaded questions that are designed to trick you into an answer. And then you have biases based on how people answer or who chooses not to answer at all. Okay, here's a great example of a self-interested study. A study funded by the Wrigley Science Institute, yep, the chewing gum people, found that chewing gum might boost teens' math grades. Now, does that mean the study is false? Well, not necessarily, but it definitely means we should raise an eyebrow, right? Because the people paying for the story have a pretty big stake in the outcome. And check out this question. This is a classic loaded question. Notice how it's framed. It's not just asking your opinion. It's giving you a choice between a reasonable-sounding tax and, well, total chaos. The question is emotionally designed to push you in one direction. Okay, so let's say you've collected your data and you've been super careful to avoid all those biases. Now you gotta show it to people. The graph you pick is basically the movie poster for your data story. It's the first thing people see, and it can totally change how they understand the information. So if your goal is just to compare different groups, like, say, how many people prefer pepperoni versus sausage, or how many students got an A, B, or C, the bar chart is your absolute best friend. It's super simple, it's clear, and you can see who the winner is in a split second. Look at this. You can instantly, without even thinking, see that meat lovers is the most popular. There's no confusion. That's the power of a good bar chart. It makes those kinds of comparisons immediate. But what if you're not just comparing totals? What if you want to show how all the parts make up a whole? Like what percentage of the vote did each candidate get? Well, that's when you pull out a pie chart. It's specifically designed to show how a total is sliced up. So, with this donut chart, the same pizza data tells a slightly different story. Instead of just seeing which one's the most popular, you see exactly how much of the pizza pie each topping gets. You can see Meat Lovers is more than a third of the total, and Poor Old Hawaiian is just a tiny little sliver. And finally, what if you're trying to see if there's a relationship between two different numerical things? Like as a tree gets wider, does it also tend to get taller? For that kind of question, a scatter plot is the perfect tool. Every single dot is one observation, plotted against two different measurements. And that brings us all the way back to our original mystery. We have our tools, we know the traps to avoid, and now it is time for the final, most important lesson for any data detective: understanding the huge, massive difference between correlation and causation. This right here is the absolute key. Correlation just means two things move together. One goes up, the other goes up. That's it. It is just an observation that two things are in sync. It's not an explanation for why. And that's exactly what we're seeing with the ice cream and the sunburns. So let's walk through the bad logic here. Step 1, we see the pattern. More ice cream, more sunburns. They are correlated. Step 2, we make the huge leap in logic and just assume one is causing the other. But this is the exact moment a good data detective has to stop and ask, hang on, what else could be going on here? And here it is. The real culprit is a hidden third variable. Statisticians call it a confounding variable. In our case, it's just hot weather. High temperatures cause people to buy more ice cream. And high temperatures also cause people to spend more time outside in the sun, which leads to more sunburns. The ice cream isn't causing the sunburns at all. The heat is causing them both. So, now you're a data detective. The next time you see a chart or a stat that tells a really simple, neat story, just take a second. Ask yourself, what did they measure? Who did they ask? And most importantly, are these two things really causing each other? Or is there a hidden story, a confounding variable that nobody's talking about? What are the numbers really trying to tell you?